A creature the size of a kaiju looks powerful, but in reality, its own weight would be its biggest weakness. The issue comes down to how size works in biology. The kaiju from Pacific Rim are massive, standing tens of meters tall and weighing thousands of tons. As an animal gets larger, its weight increases much faster than the strength of its bones and muscles. Bones can only support a certain amount of stress before they fail. Even the largest dinosaurs had to evolve thick, column-like limbs just to hold themselves up. A kaiju, at many times that size, would put extreme pressure on its skeleton, far beyond what biological tissue can realistically withstand. There's also an important difference between land and water. In water, buoyancy helps support body weight, allowing much larger animals, like whales, to exist. However, even whales have a limitation on how far they can grow. As size increases, energy demands and biological constraints begin to outweigh the advantages, limiting further growth. But on land, there's no support like that, and so, if a whale got beached, they would succumb to their own weight. A kaiju would have to carry its entire weight through its legs, making extreme size far more limiting. For comparison, the largest land animals today, like elephants, already operate close to their structural limits. Scaling far beyond that quickly becomes biologically unstable. And it's not just standing still. Walking, turning, or accelerating would multiply those forces, making movement slow, unstable, and incredibly risky. So while a kaiju might look unstoppable, real-world biology suggests it wouldn't even be able to support its own body for long, let alone move the way we see on screen. At a certain point, getting bigger stops being an advantage and becomes a limitation. Thank you for watching. If you would like to see more content like this, please give a thumbs up and subscribe.